Grade 12 Physical Sciences learners. Audio 4 on Electrodynamics. Today we are looking at the alternating current AC generator, its advantages over direct current generator, DC generator, and define also the RMS for the alternating voltage Vrms and alternating current Irms. AC generators are mainly used in the real world to generate electricity. Power stations produce energy in the form of alternating current AC, then transform it into direct current DC. Power is the rate of change of energy. P is equal to VI. Power is equal to potential difference multiplied by current. Have a look at the following diagram. Alternating current generators, AC generators, are used at the power plant to generate electricity. The main advantage of AC generator is that the voltage can be changed using transformers. The voltage can be stepped up at power station to a very high voltage so that the electrical energy can be transmitted along power lines or transmission lines at low current and experience a low energy loss due to heating. So that's why I always say it is dangerous at least to put your house under transmission lines. The voltage can be stepped down for use in buildings by using substations, for example Eskom. What they are doing there at Eskom is to convert the alternating current, the AC current, into direct current using a direct current generators. So that's why they are always being replaced now and then during this time of load shedding. In direct current generator, the current and voltage are constant. Current depends on the resistances contained in the electrical circuit. In an alternating current generator, the current and voltage, they fluctuate or vary with time. Let me repeat this. In a direct current generator, the current and voltage are constant. In an alternating current generator, the current and voltage fluctuate or vary with time. AC varies in the form of sine graph as indicated in the previous topic. The power in a transformer remains constant. Then now let's have a look at the maximum voltage or at the peak voltage or maximum current or peak current. So in the following graph, we are having the maximum voltage against time, figure 7. So it means the voltage fluctuates with time. Then the second graph, figure 8, have a look at the graph of the maximum current that fluctuates with time. If I ask, what is the maximum voltage in South Africa? Others will say is approximately 240 volts. Others will say is 325 volts. Check at home the electrical appliances, e.g. the kettle, the iron, power extensions, the fans, and so on. Power fluctuates with time. The maximum or peak value of the voltage, V maximum, in most South African homes is approximately 220 volts to 240 volts at a frequency of 50 Hz. Power, voltage, and current fluctuate with time. Scientists opted for the power average in an AC circuit called the RMS or root mean square. The RMS of AC is the DC potential difference, which dissipates the same amount of energy as AC. The RMS value of AC is the direct current potential difference, which dissipates the same amount of energy as AC as alternating current. For calculations, a formula are available in the data sheet under current electricity. You just put the subscripts. For example, power average is equal to Vrms multiplied by RMS. Then if you want a Vrms is equal to V maximum V peak over square root 2. V maximum as illustrated in figure 7. Then IRMS current is equal to I maximum over square root 2 as illustrated in graph 8 or figure 8. Then also for calculations, power average P is written is equal to I squared R. Then for power average, power average is equal to I squared root mean square multiplied by resistance. Is the power and current that fluctuates. Maybe you are required to calculate a resistance not given at the voltage. Then also a power average is equal to V squared root mean square RMS over R. So maybe we are required to calculate something not given at the current. So in those formula that are written on the data sheet, so you just put the subscript. For power average, for voltage you put RMS, for current you put RMS at the subscript. Let me have an example in one of the previous question papers, since this is the only section in this topic where you are having calculations. The problem we're having, an electric device with resistance at 11 ohms is connected to an AC source, alternating current source, with an RMS voltage of 240 volts. Calculate at the maximum, in brackets, the peak current passing through the device. For the solution, you start by writing the data. Power average is equal to 11 ohms. Vrms is equal to 240 volts, and you are required to calculate the current maximum or current peak. The formula appropriate, a power average is equal to Vrms multiplied by IRMS. Therefore, IRMS is equal to a power average over Vrms. Then when you substitute, the power average is 11 over 210 volts. Then the answer for current RMS is equal to 21,82 amps. You can check. Then you are required to calculate the I maximum, the maximum current or the peak current. The formula IRMS is equal to I maximum over square root 2. Then the I maximum would be IRMS multiplied by square root 2. Then if you substitute, it's 21,82 multiplied by square root 2. Then we are having 30,86 amps. Do as many examples as possible from the previous question papers. With these 4 audios, you can answer any question from the previous question papers. Good luck.